oftentimes the most painful bugs are the ones that take a long time to debug because they're so hard to track down. The behavior is unpredictable when you're actually trying to debug the code. You said it took you days. I mean, are we talking literally, dozens of hours of man time just to track this one down?
Yes, unfortunately.
Yeah, so that is the reality of defects. So I guess, now you're in charge as a director of development of trying to, get a whole team of people together to build a software system. And, I'm sure many of the developers that are listening on this call, as well as many of your developers, have experienced that type of defects and others that are just a real pain to track down. What are some of the things that you're doing from a process standpoint, as well as a technology standpoint, that you've seen work very well with developers in the past?
As you say, it's processes. Some engineers hate to talk about process, but from doing something that's repeatable, then having a framework in which to do that is very important. And we are an ISO 9001 certified company, and so we have a certain framework. Is it perfect? No, but we're always looking to do things better. And the process we employ is fairly straightforward. It's very similar to many things going on in the industry. Everything's under source control. We have a defect tracking system. We have a test case management system, and they're all tied together. And we have infrastructure that allows us to do nicely load builds. So as developers submit their code, they are able to get feedback as to how it fits and integrates into all the other submissions that take place. It's all very well doing your own development in isolation, but when it has to interact with other people's new submissions, then that's when things can get interesting. So we have that being performed on a daily basis. And on a weekly basis, we create a production load that is then used for extended SQA testing as appropriate, depending upon where we are in the life cycle of the release.
So just jump into your developers, then you talk about this nightly build. Are they given feedback from that automatically? Or how do they find out, once they've checked in some code, what happened with that build process?
At the end of the build process, there's a couple of things that happen. An email is sent out detailing the success or otherwise of the nicely load build process. And one of the conventions that we have for formal load builds or production load builds is that there aren't any warnings or any errors. Obviously, if there's errors, you don't get a load, of course. But if there are any warnings indicated by the compiler, then the developer is responsible for eliminating those errors.
In fact, you have a requirement that the code goes through compiler warning free, essentially.
Right. One of the other things that we do is we also have a regression suite of automated test cases. So the load gets built, and we then take that software image and apply it to the product under development, and it executes the automated test suite. It's like a basic regression suite. We call it Sanity, and get the results from that for those test cases. Everything passes, all those passes are indicated in the email that's sent out to the development community. If there are failures, then the failures are examined, and depending upon the failures, the appropriate developers asked to take a closer look as to what's going on.
Excellent. So it sounds like it's a very proactive system in terms of informing developers when there are issues and encouraging them to look at them as quickly as possible in the process, so it's not saved off until right before release or something like that.
Right, and that's one thing we found in general, that it's better to provide the information to the engineers first, and that gives them the opportunity to take care of things before anybody else gets involved. So it's really a question of providing the tools to the engineers to assist them in getting their job done.
Absolutely. If anything, have you had any experience with technologies or processes that just don't work very well? They don't resonate with developers, and the developers don't latch onto them, and just can't, it can't work. And if so, so, what are some caveats for other development managers or developers who are looking for good practices? What are some of the cases that work well?
What I've seen in the past is things that don't work well, and I would say the classic. I think everybody has seen the statistics in terms of code inspections being very valuable to do, but actually trying to get a group of engineers into a office and do code inspections properly is an altogether challenging thing. They have the difficulty of seeing the benefit for doing so versus I'm under the gun to get features and functionality or things fixed in a short time frame. The other things I've seen not work well is where the developer doesn't understand what the benefit is, or it's not something that directly helps them in their job and being able to get those things taken care of or features implemented. So having some what works well is giving the engineers their tools that do aid them in their job and allows them to do their job in a better or higher quality fashion.
Excellent. Now, I know you've been a Coverity customer for some time now, and you've got some slides that we'll talk about to introduce our general question and answer session. But what are some of the other technologies or process improvements that you're looking to make to really help drive your engineering organization forward to even a higher level of quality in the future? Are there other things that you're thinking about, ways that you could streamline even better, optimize your processes or technologies even more so that you have higher quality software?
We're always on the lookout for new things, and that was one of the reasons we took a look at Coverity and other similar products from other vendors. And Coverity was one of the first ones that we found that the issues identified versus I'd say the noise in terms of I wouldn't say false issues, but things that weren't of little importance. Coverity was the one that had the right ratio, and what we've done is integrated that into the developer's environment, where we've provided the environment to allow them to execute the tool on their own code prior to saving it in the source code environment. And also integrated it into the load build environment. That at the end of the production load build, we create a summary email outlining all of the issues that have been highlighted by the Coverity tool. And what we found over time is that the engineers are using that information to whittle away the issues. So that's how we've enhanced our development process to date. In terms of looking towards the future, we're always on the lookout for new things, whether it be real-time embedded tools that allow us to capture the execution path of the processor, or memory management or source level debugging, which is fairly standard these days. So we're on the lookout for things. One of the things that we're quite interested in seeing work well in the workstation space is the runtime memory checking and boundary checking analysis. There's a set of tools out there. Unfortunately, not any, as I'm aware of, that are available for the embedded space as yet.
Right. So you anticipate, hopefully someday, being able to leverage more runtime type tools in the embedded environment.
That would be great. And with the advances in memory and processor speed, then we're getting to the point where essentially we have little workstations built in. In fact, our